Hi, my name is Itamar Turner-Trauring, and I'm a trainer, writer, and software engineer. And today I'm going to be demonstrating a number of techniques that can help you debug problems with your Docker packaging, with your Docker containers. And I strongly encourage you to open a terminal and actually type along with me as I do these techniques so you can practice them yourself. I'm going to be going through them pretty quickly because it's a very limited time compared to if I was teaching this as a class. And yeah, just doing it yourself is a great way to do it. If you're watching a recording with a pause, you can just pause, type, and keep going if it's going too fast. And before we actually look at these debugging techniques, I just wanted to recap or clarify two basic core concepts in Docker that we're going to be just saying over and over and over again today. And so I just wanted to make sure that the difference between them is very clear. And those concepts are image and container. So if I look at my computer here, I have a whole bunch of processes running. I can run ps exe and just got a whole long list of processes. And so processes are a program that's running. When you run a process, you start out with an executable, a file on the file system. So I just ran ps. If I do which ps, I can see that there's a file, bin ps, executable on the file system. And so when I run ps, that's the executable that started it. And so we have an executable, and then when you run it, you get a process. Similarly, an image is a self-contained file system that contains all the files you need to run a container. And a container is the first approximation, a running process that's somewhat isolated. So an image corresponds more or less to an executable, and a container corresponds more or less to a process. So a container is a thing that runs, and an image is sort of an inert set of files. Okay, so now that we have that clarified, let's look at our first technique. So let's say we have a Docker container running, and I'll give this a container a name. And if you don't give it a name, Docker will just randomly assign it a name, and each container has a unique ID, but by giving it no name, that sort of simplifies talking to it. I'm going to use a detach argument to run in the background, and I'm going to run the httpd:/alpine image. So I'm just running container off of this image. It starts up, prints out the very long container ID. So this container is running. Like we can see, if we do docker container ps, we have this container running. But I'm sort of curious, what's going on inside that container? Like, what does a file system look like? What processes are running inside of it? What's just going on in there? And so just like you can SSH into a remote host, you can actually get a shell inside a running container. And so what you do is you do docker container exec. And then you're going to do -IT option to tell it this is an interactive command. And then the name of the container, or its ID. And then the command I want to run. So I'm going to run bin sh. And many containers will be able to use bin bash, or just bash, and then you'll get a nicer shell. In this case, there is no bash, there's only bin sh. And so I do that, and now I have a shell. And the shell is inside the running container. And so what that means is I can look around. I can look at the file system. There's an htdocs file with an index.html. I can also run ps, and I can see what processes are running. And I can move files around. Basically, everything you can do if you SSH into a remote server. And so this is a great debugging technique because you can just poke around in a running container and see what's going on there, what it looks like. And then even if you want, even modify things just to see if you can fix something or diagnose something that way. So that's the equivalent of SSH. So another thing you can do is just like you can SSH into a remote host, you can also copy files in and out of remote hosts using the scopy command, scp. Similarly, if you have a running Docker container, you can copy files in and out of it. So for example, we saw above when we were poking around that there's in user local Apache 2, there's an htdocs folder with an index.html file. So I'd like to copy that file out and take a look at it. So I do docker container cp for copy, the name of the container, which I know is HTTPD because I named it. I could also use the container ID right over here. So D3398. You just have to use the first few letters as the prefix. The docker container, the container name, and then I do a path. So we can see that it's user local to htdocs index.html, and then I just copy it to the local directory. And now I have this file in my local directory on my host machine, and I can look at it, I can open a text editor, and if I wanted to, I could modify it and then copy it back into the container and replace whatever file is there. And so you can go both ways and copy files in and out. So let's delete that file. It's all gone. Let's clear my screen. And by the way, if you are trying to sort of desperately take notes, I'm going to, at the end of the talk, give a link to a cheat sheet that summarizes all these commands. You don't have to memorize anything, but I do encourage you to practice it. So, we've copied files in and out of a running container, but what about what happens if a container dies? Like your server crashes, but it has some file in the file system you still want to access, like a log file or a core dump. So it turns out, when a container exits, by default, unless you told Docker otherwise, the container's file system just sticks around even if the container is dead. So if we look here, so we have this running container, my HTTPD. So next I'm going to stop it. Okay, it's shut down, it's gone. So if I do docker container ps, it's no longer there. But if I do docker container ps-a, short for all, I can actually see all containers, all meaning all the running ones are also all the dead ones. And my HTTPD actually is still here. And you can see that it exited with exit code 0 about 11 seconds ago. So it's dead. But its file system still exists. So just like I can copy files out of a running container, I can also copy files in and out. Copying in is a little less useful, but I can copy files out of a dead container. So I can do docker container cp, actually. Just as a reminder, our current folder is empty. So docker container cp, and again, I just use the same syntax. Name of the container or its ID, user local to htdocs index.html. Now I copied a file out of a dead container, which can be useful if something crashed and left behind some sort of debugging information. So let's clear the screen. And so far we've been talking about just containers. So let's move on to talking about building images and what can go wrong there. So I'm going to create this Docker file here. And sort of nothing very exciting. I'm going to use this Python base image, and it's going to copy in a build script, and it's going to make it executable, and then I'm going to run it. So this is sort of, your standard Docker file, has some sort of build script that's going to do some work. But what I'm going to do is by the way, you can use your own editor. I'm just using gedit because it's what I have, and it's simple enough, but use whatever editor you want if you're following along. So I'm going to edit the build script, and what I'm going to do is I'm going to simulate a particular failure mode. And that failure mode is, if you're running a build and it fails, quite often it'll just print out the error as part of the output of the build. So it'll say, build failed, missing this header file. And so you say, oh, I forgot to install the header files for that library. Or build failed, syntax error in your code. And say, oh, I'll fix the code. Sometimes, however, you will get an error that is written to a log file. And so that's what I'm going to simulate. So I'm just going to do this little song and dance, which basically is going to be a pip that's going to write out some errors. It's going to fail, and it's going to write out the error to /temp/pip.log. And so let's see that failure, and then we'll talk about why this is a problem. So run the build, copies the file in, runs it, and it errors out. All right, that's fine. We can debug this. But we have a problem. If we were running this on our local machine, the log file would be somewhere on our local file system, and we can just look at it. But here, the build step is happening inside Docker image build. So it's not our local file system, it's a Docker file system. And so where exactly is that log file? How do we get to it? It's not clear. And so to understand how we can get to that log file, we need to understand how exactly Docker builds work and how and get a sort of better understanding of all this very useful but a little bit opaque output over here. And so if you look at the output here, we have a series of commands. Basically, for each line of the Docker file, to first approximation, it's a step. With each step, it is creating a new layer. And so that layer has its own ID. And effectively, that's a new image it's creating in each step. So this is a new image, and this is a new image, and this is a new image. And then when we get to a run, so we run chmod plus x. So it says running in FAB32, and then it says removing intermediate container FAB32. So what happens is whenever you have a run command in your Docker file, what Docker build is doing is it's taking the previous layer, which is just an image, and it's running a container off of that image. And if it succeeds, it just cleans it up. But if it fails, it actually sticks around. And so we can see that if we do docker container ps -a, that build.sh over here, it's a dead container that exited with a non-zero exit code. It failed. And we look at the image ID, D9918. That image ID is the image ID of the previous step, the previous layer in the image. And the container ID is the ID right here. And so each run command creates a new container. If it fails, that container sticks around. And just a couple of minutes ago, we saw that we can copy files out of dead containers. So we can do docker container cp, and then the ID of the container, so this, so F429, 6. Again, you only have to do the first few letters, and we know it's in temp pip.log, and we can just copy that into the host directory. And now we just have a file that we can scroll through and eventually figure out the error. It's a pretty long log file, so I'm not going to do that, but now you have the log file on your machine, and you can just open your text editor and search it, and you're good. So you can, if your build fails, you can actually access the failed build steps, the failed run commands as dead containers. And so next, let's see what else we can do with a failed build. And so one thing that's often useful when you're debugging is to reproduce the problem. And you want to reproduce the problem in as realistic a environment as possible. And so let's see a problem in a Docker build, and then we can try to reproduce it. So I'm create a new directory, nothing in it, and create a new Docker file. So again, we're going to use standard base image. We're going to copy requirements.txt in. We're going to change to a different directory, and then we're going to install requirements.txt. And then we'll write out a little requirements file. And so that's the Docker file. It's just a basic copy file in and install it. And that's requirements.txt. So simple enough. You may have noticed the bug I introduced, but then again, you might not have. And in the real world, you will have, unexpected errors, unexpected problems. And so you want people to sort of reproduce those problems and then debug them in a controlled environment. So let's see the failure. So I do docker image build. And says could not open requirements file, no such file or directory. And so our goal now is to try to reproduce that error in as realistic an environment as possible, which is to say I want to have a running container with a file system as it was right before this command, and I want to be able to run that command manually and then poke around and see what went wrong. And so you'll recall that we talked about how each step in the Docker build creates a new layer. So this is a layer, and this is a layer, and this is a layer. And then this command runs off of the image that is the previous layer. And so this is the ID of an image. And just like any other image, we can run it. Or rather, we can create a container whose file system is based on that image. So let's do that. So we'll do docker container run. And we'll want to be interactive. We want the entry point to be a shell, so we can poke around. And we are going to give the ID of this layer, the previous step that succeeded in the build. And so now I am exactly where step 4 was when it failed. And so if I were to try to run step 4 manually, it fails in the exact same way. So I reproduce the problem. The difference being I am now inside a shell, inside the container, so I can look around and say, oh, there's no requirements.txt here. Where did it go? And then I can look at the Docker file and say, oh, I changed directories. If I look in the root directory, that's where requirements.txt is. And so I can now go and fix my Docker file appropriately. But it's much easier to debug because I'm actually have a shell in the same environment where the Docker build was running and then failed. So just to recap, we've seen how you can get a shell in the running container. We've seen how you can copy files in and out of running containers. We've seen you can copy files in and out of dead containers. We've seen that each step in the Docker build creates a new image, so we can run an image off of it. And we've also seen that a failed run creates a dead container, and we can copy files in and out of that dead container to extract log files. And so let's see yet another example of a failure mode where you want to reproduce the environment where that failure happened. So we create a new directory. In this case, our Docker build is going to succeed, but when we run the container, it's going to fail. So we're going to write a very simple Docker file. It's going to copy a script in, and then when you run a container off of this image, it's going to have an entry point that says, when you run me, you should run python script.py. And to simulate a failure, I'm just going to so here's a Docker file, and here's a script. And in this case, this is like a completely simulated error. But in the real world, you might run a script and then get an unexpected error, and then you might want to reproduce that error in a realistic environment within the actual image where the problem happened. And so what you can do is build image and give it a name print. And so now we can run that container and we get an error. And so I want to reproduce this error. I want to run the entry point, but I want to run it manually inside this exact image. So what I can do is I can say docker container run and my interactive and do the shell as an entry point, but I can still use the image. And so now I have a shell in that image. And then I can just manually do what this entry point does. right? So I can do python script.py. I got the same error, and now I've manually reproduced the issue, which means I can actually look at the code, I can look at the environment variables, I can look at the file system, I can debug the problem within a realistic environment that matches where the code is running. But I have a shell, which means I have actually a lot more abilities to debug the problem. Okay, so let's clear the screen and go up a level. And so next, I'll talk about another technique which involves containers, which is sometimes your container will crash, and you want to know why. And so we already saw that if you have a dead container, you can copy files in and out of it. And that's useful. But it presumes we know exactly where the files are. And it's still not, it gets us files, but it doesn't give us a realistic reproducing environment. Like you might want to try to run the command again manually inside that container. Or you might want to change something, or you want the same environment where that process failed. You want it back up again, but with an image that you, like a shell session that you control. And the problem is that, as we talked about in the beginning, a container is basically the equivalent of a process. It's a thing that runs, and then it exits, it's dead. So you can't get a shell inside a dead container because it's dead. There's nothing there. But what you can do is actually create a new image from a dead container. And then once we have a new image, we can start new containers off of that. And let's see an example of how to do that. So I'm going to run a container. I'm going to make it interactive. I'm going to run bash. And I'm going to run it off the Python image. And so I'm going to simulate some server running, writing some files out to disk, and then crashing. So let's pretend we ran an image, wrote a file to disk somewhere, and then it crashed. I want to know what happened. And so if I look here, there's a dead container here. I'll name my container too. And so what I can do is I can do docker container commit, the name of the container, and then I can create a new image off of that dead container. So I'm going to call it debug. And so now I can do docker image ls debug, and you can see I have a new image. And an image is a thing that I can run. So I can do docker container run -it entry point equals bash debug. And it's a container. I can look around. But it's a container that's created from the same file system as that dead container we had earlier. Which means I can, for example, access that file that was created in that original container. For example, a log file or a core dump. And so now I have this debugging environment with a shell which matches that dead container, where I can try to debug the problem and diagnose it. So at this point, we're basically out of time. But as I said, you can get a cheat sheet with a summary of all the techniques I've covered in this talk at https://pygotham2020. And if you're interested, you can also read my free guide to production-ready packaging of your Python applications for Docker. There's a lot of details to get right. If you're interested in my training or other products, you can also learn about them there. So again, thank you for watching along with me. I do encourage you, if you didn't do it already, to go along to practice this talk with a terminal and just type all the commands yourself. And if you go to this URL, you can get a cheat sheet. And thank you very much.